Hi guys, Mrs. Delise in here. Welcome to another lesson of Algebra 2. Today's lesson is log to exponential. We will learn how to solve log equations. We will also learn how to solve log equations with a known base. In Exponentials 4.2, we studied how to solve equations that had a log on both sides. In this section, we will examine what to do when the side of an equation has a log, but then the other side is only a number. Let b and x be a positive number, where b is not equal to 1. To solve a log equation in the form of log base b of x equals y, you have to rewrite the equation in exponential form first, and then you are going to perform additional steps to isolate the variable if needed. So let us check. First, we have here log base 4 of x equals 3. We are going to rewrite this log form into an exponential form. So this is 4 to the power of 3 equals x. And 4 to the power of 3 means 4 times 4 times 4, and that is 64. And just like that, you have your x value, which is 64. And again, because we have a logged in here, although it's not mentioned in here, we have to make sure we check our solution, yeah? But if I plug in 64 into there, it's not going to be a negative, so we're good to go, right? Or you can just say checked in here. And obviously, log base 4, it's not a negative number inside our argument. So we're good to go. Moving on. We have log base 5 of 3x plus 7 equals 2. We have to rewrite them in exponential form. So that's a 5 squared equals a 3x plus 7. 5 squared is 25 equals 3x plus 7. And let us subtract 7 on both sides. We are going to have 18 equals 3x. Divide by 3 on both sides, we have a 6. Okay, so if I plug in 6 into the log, that is a very obvious that it's not going to be a negative number. So we are good to go. So log base 5 of 25, right? 18 plus 7, that's a 2. Okay? And if you want to check further, 5 squared is 25. So we are good. Moving on. We have 2 to the power of 4 equals x squared minus 6x. So we have an x squared going on. Looks like we're going to do a quadratic, right? We're going to factor or completing the square or quadratic formula. If it's not factorable, so of course we have to do completing the square or quadratic. But if it's factorable, then it will be easier. 2 to the power of 4 is 16 equals x squared minus 6x. So we need to move the 16 onto the other side. So we have x squared minus 6x minus 16 equals 0. And, this looks factorable. X minus 8 and x plus 2 equals 0. So we have our two values, x equals 8. And then we also have x equals negative 2. All right. But we need to make sure if I plug in 8 in there, it will be a negative. If I plug in a positive 8 in there, make sure it's not a negative number. If I plug in a negative 2, make sure it's not a negative number. So let's log base 2 of 8 squared minus 6 times 8 equals 4. So we're going to have log base 2 of 8 squared is 64. Or should I okay, let's just put that in there. Okay, I don't really have to put the 4 in because I just need to make sure that my left side, the one with the log, will not include a negative exponent. So this is oh, not negative exponent, negative argument. Log base 2 of, that's a 16. And then if I plug in the negative 2, also 8 works. Let's try negative 2. That's negative 2 squared minus 6 times negative 2. Log base 2 of negative 2 squared is a 4. Plus negative 6 times negative 2 means positive, right? A negative and a negative, so it'll be a positive 12. So that is also a 16. Okay? So that's it. And that didn't get into a negative number, so negative 2 also works. All right, moving on. Okay. So in here, the missing number is the base. Yeah, so we're going to solve for the base. Let's start with b to the power of 5 equals 243. So I want to solve for the value of b only. So I'm going to, let me make that in red. I'm going to do this. So fifth root of the 243. So this is b equals the fifth root of 243. Do you guys still remember this? I can make, if you have those high-end calculators, those high-end calculators can do a fifth root of 243. But usually calculators, I think, have like the simple ones, have like a cube root or something. So how do we solve this one? How do we show our solution? I can make a factor tree of 243. And that's 9 and 27. That's 81 and 3. There's so many. So we can do 9 and 27. That's 9 and 3, 3 and 3, 3 and 3. So this is 1, 2, 3, 4, and 5. So this is 3 to the power of 5. So our answer is b is equal to 3. All right, moving on. B to the power of negative 3 equals 1 over 8. And since this one is a negative exponent, I will rewrite that as b 1 over b to the power of 3 over 1, 8. And so I want to make these equal to this one. And since you guys take a look at their their numerators, since the numerators are already equal to each other, I'm going to focus on these two things at the bottom. So let me put a square on that. There you go. And we are going to solve b cubed is equal to 8. That is a cube root of 8. So this is b equals 8 is 2 to the power of 3, yeah? And you should know that the cube root of 8 is 2. So b is equal to 2. So our answer there is 2. And just like that, we are done with number 4 and number 5. So we have 2 more things to talk about. And here's the next page. All right? And I need you guys to pay attention on this one. As you will encounter oftentimes in math, not all numbers will be nice numbers. Okay? Such will be the case with base values as well. In geometry, you studied extensively a special number called a pi. And we all know that that is the equivalent number of that is 3.14159 and so on and so on. Right? And because it is seen frequently enough in math problems, it was able to obtain its own special symbol. As we continue our path towards studying log and exponential functions, another such special number will appear in our lives. This number is called e. Okay? An approximation of its value is shown below. So we have 2.718 and so on and so forth. And just like the pi, right, we just need to remember approximately this part of it. That e is equal to 2.718. Okay, the value of E. So it's not like it's a letter, but it's actually a number, right? So the value of it is 2.718. Now, I would like you to go in your calculator, right? And go look for the symbol E, right? Usually, it is E. It looks like E to the power of X. Or in most cases, it will just be E to the power of like this, the caret symbol. Or like, where do you find it? Usually you'll find this one on top of ln. That's not an I, by the way, it's an ln. Usually you'll see that on top of ln. Okay, then let us move on. Like pi, the number E is irrational, meaning it cannot be written in fractional form. The decimal value shown is also an approximation because the decimal representation actually continues on forever. It is useful to memorize the first three decimal values. Almost all scientific or graphing calculators also have an E button. For calculators that also have keys for letters, like the graphing calculators, you need to be careful not to use the letter E button, but rather the number E button. Okay? In Exponentials 2.3, we saw that log with base 10 are used frequently enough that we often leave off the subscript 10. This common log, written as log, you see have no base because the base of that is 10, are frequently used in sciences such as in chemistry. Mathematicians, however, tend to use log with base E much more frequently. As such, we also have a shorthand for this as well. So for those who will be taking higher math, since I teach AP statistics, so to those who will be taking advanced statistics, you guys are going to encounter ln and E in AP statistics. So this is something that sciences actually would use, okay? And any sciences and any mathematics, and also, of course, calculus. Base E log are called natural logarithms. Natural logs are usually written with ln, small letter L, right? ln, not in, instead of log base E. So that means when you have, this is log, no base in there, that is called the common log. But then when it's written as this, right, with the E as the base, this is called a natural log. And natural log here, log base E of x can also be written as ln of x. So whenever you see ln of x, that is just a log with a base of E. Okay? And in the future lessons, you would be seeing, okay, so when do I use this E? But for now, we are going to just make sure that we know where to get this in the calculator, so we'll have easy transition. Almost all scientific and graphing calculators should have an ln button. The ln button is specific to base E or natural log. On some models, we may need to type in the argument first, then press the ln. So let's say, for example, ln of 32. You might want to have to press 32 first and then press the button ln. Some calculators, you would have to press ln and then it will provide you a parenthesis that you could put 32. So whatever calculator you have right now, I would like you to start doing that and figure out, oh, okay, in my calculator, I have to press 32 and then press ln, or the other way around. Okay? So, recall in Exponentials 4.4, we learned how to solve log equations with an unknown argument. The same procedure applies when using natural log. So, I only have 2 examples in here. And hopefully, these 2 examples will be enough in order for you to understand how to rewrite ln or log, natural log with a base E. Okay. Since I have a formula earlier, or not really a formula, but like a guide, that whenever I have something ln of x, I can rewrite this as log base e of x. So I'm going to rewrite this ln of 2x minus 7 into log base e of 2x minus 7. And hopefully that makes sense. Equals negative 3. And now it's easier for me to write this one in exponential form. So I have e, same thing as what we did earlier, to the power of negative 3 equals 2x minus 7. Okay, I'm going to rearrange that. I'm going to put the 2x minus 7 on the other side so that I'll have an easy transition. Okay, just because. There you go. Okay. And you can solve e to the power of negative 3 right now. Now, how do we solve e to the power of negative 3? Sometimes calculators will have a symbol e with this. So all you have to do is you press e, and then it will appear that you'll have e with a caret, and then you can just put negative 3 in it. Right? Other calculators though, you have to type negative 3. Make sure you're not minus 3. Okay, and negative 3, there's separate buttons in your calculator. So I'm going to do a negative 3. And then usually I have to do shift or maybe second function, whatever your calculator has. And then I'll press ln. Okay, because on top of the ln, you'll see e to the power of x. And that's what we want, the e to the power of x. So that's why we have to click shift or second function. And hopefully, once you're done with that, you'll get a number of 049787068. Okay? And then what you're going to do is you're going to add 7 on both sides. Right? So 0.049787068 plus 7. And since I already have all the numbers written in there, I am just gonna, after I add 7 on my calculator, I'm going to divide that answer by 2. And hopefully you'll get this answer. And I just need the first 4 decimal places. So that's a 3.5249. There you go. Again, I'll repeat. You do this first in your calculator. Once you get the answer to that, you add 7. And then you divide by 2. Okay, moving on. I'm going to, again, rewrite this one as log with a base of e. X squared plus 5 equals 3. I'm going to do e to the power of, e to the power of 3 equals x squared plus 5. I'm going to rewrite them, the x squared plus 5 is in here, just so that I like my, whatever is missing or whatever I'm solving, right, I want it to be on the left. Okay. And then I'm going to solve e to the power of 3 in my calculator. Again, whatever symbol you have, you can do that. Or you can type 3 first, then click shift or second function, and then go to ln because the e to the power of x is in there. And hopefully, once you're done with that, e to the power of 3 will give you 20.08553692. And please do not round at this point. And then I'm going to do subtract 5 on both sides. So this is x squared equals 0.08553692, right? 20 minus 5. And then I'm going to square root both sides of the equation. So I'm going to have x equals, remember, plus and a minus. Hopefully you will get this in your calculator. So our final answer is a plus and a minus 3.8840. All right, and that's it, you guys. I am hoping that you are able to use this video to finish your homework today. Thank you, everyone, and I'll see you guys on the next video. Bye.